Thing has begun. This is day 4, week 3 of our journey together, summer 2022 classes, and it's a joy to have each and every one of you here to these classes. We have just finished a very important topic that would be rules of exponents. We went through all of the rules that you would need to know at your level. I know I said 6 yesterday, but when I watched the recording, I noticed that I said 6 rules that we covered, but we covered more than 6 rules, so that correction on that. But today we're gonna move from rules of exponents and dive into another topic, which would involve, at least in some aspect, rules of exponents eventually. But at first, we're gonna start small, and some of you might already be familiar with these type of questions, but for those who need a refresher, for those to whom it's new, hopefully we still can have a good time with this topic. All right, so let's begin. We have, today is actually Thursday, so I want you to please take out your notebook and your pencil or pen and copy down these notes for me, please. And as usual, at the end of the class, I want you to send the class notes to me. Some people are still not sending the class notes. That is unacceptable. Please send the class notes right after class. All right, so today is the 21st of July. Believe it or not, it's almost time for school again. I know you might not be happy to hear that, but it's almost time for formal school again. We're already in July 22nd, and so July 21st rather. And so, school is right around the corner because we're basically close to August, basically close to August. So, yep. One more week and then we're in August. And then after August, some students, some school begin in August, and others it begins in September. So if your school begins in August, you know that school is right around the corner, even more. But if your school begins in September, you have a little bit more time, but it's still right there. All right, so hopefully these classes can at least keep you in the frame of mind for school. So when you get into school, it wouldn't be so foreign. You'd still be used to certain things. All right, so we want to look at brackets and factors. All right, that's the brackets and factors. That's the general topic. I guess we'll say this is a general topic, and I'd say part 1 because I bet that we're gonna be here for a while. So we're looking at brackets and factors. The first thing we're gonna look at is section number 1, and section number 1 is entitled Simplifying Algebraic Expressions. And I know we have done simplifying algebraic expressions of the type of, with the rules of exponents, but today it's going to be slightly different. All right, so remember, for those who know, remember that terms containing the same letter can be collected. So that is to say, we can collect or group like terms. Like terms are also special because with like terms, we can always add and subtract them with one another. So it's very important with like terms. So like terms can be collected and grouped, and we can actually perform operations with them. We can add with them and subtract with them with no problem. All right. However, when it comes to unlike terms, this is not the case. We cannot, or it is not mathematically correct to add or subtract like unlike terms. All right. And so we got to break down what we mean by that. However, when it comes to unlike terms, this is not the case. We cannot add or subtract unlike terms. So let's break down what we mean by like terms and unlike terms. So when we say like terms, let me give you some examples. So like term, so I guess we can create a box, and in that box we can have an expression, well, not an equation, but we can have expressions and expressions, and on the other side we can determine why they are like terms. What's the reason? Okay. So there's different examples that we could consider when it comes to these things, and I think that examples help. They really help to help you to understand what's going on now. So let's find a good, nice border. Yeah, let's use blue. All right, so you're gonna say algebraic expression. Algebraic expression, and here we're gonna have like terms, or you can say reason why they are like terms. So let's begin. So basically looking at the differences between like and unlike terms. So let's begin with like terms and really
Wait, I will keep that first. I was on the last line.
on the last line or the first line. Okay, so let me expand it a little bit, and then there we go. Maybe I just too much. Okay, or maybe this is just the font is just too big. So let's see. All right, one moment. Let me adjust the settings here so that we can move on yet be able to see everything. Let's move this to the center. Let's take this and put it to the center as well, in a sense. Can we do that? Do they allow that? Alright, let's move this up too. Okay, I guess not, so let's leave it like so, as such. So let's say, for example, x and we can say, I guess we could add another table and say maybe we can have what it'll be. I think this is very important, like what it'll be. So we're gonna make a third column, like what exactly is. So insert another column to the left. So I really I want us to look at so we can look at, so we can say simplification. We can say performing result of operation. So if we look at on the terms, so if we look at x and say 2x, we're looking at x and 2x. So x and 2x. I don't know if we're gonna start off with x and 2x. Let's just start off with x and x. Okay, so are they like terms? Would we say? We can
Yeah.
say maybe we can add a column that asks the question. So like or unlike terms, and then maybe we can have a reason why. Okay, good. All right, so let's say, well, x and x, are they like terms, first of all? Albernate, what do you think? Is x and x like terms?
Yes.
Okay, yes, they are. Um, the reason why is because they have the same letter, right? So same letter. Um, now, if we were to try to add them together, say, I want Altwinic to help me with this. If I say x plus x, what is that gonna be? X plus x.
Reason why? Same letter?
So x plus x. What is x plus x? That's gonna be what?
2x.
Excellent. 2x. So x plus x is 2x. All right. So that's that. So x plus x is going to give us 2x. Let me expand this some more. Let me put this over. Can we do that? This thing really acts weird once it's not in that mode. Okay, so x plus x is 2x. And yes, they are like terms because we're dealing with the same letter. And like we said, terms containing the same letter can be collected. What if we have, say, let's say we add p and 2p. All right. Are they like terms? Sierra, and what if we try to add them? What do we get?
I don't think they are like terms.
You don't think they are like terms? Okay.
No, but if you add it, you get 3p.
You don't think they are like terms? Okay. Okay. Anyone agree with her? Disagree with her?
No, sir.
No, sir.
They are like terms.
They are like terms. Excellent. Okay. So why you believe that they are like terms?
Because they have the same letter.
Yes. So because they have the same letter, the number in front doesn't matter. So the coefficient doesn't matter. Same letter, coefficient doesn't matter. So they're still like terms. So we're looking at um, p plus p plus 2p. But you know, Sierra, the mere fact that you say that you could add them, they are like terms, right? So that's something. That's something, right? So p plus 2p is 3p, and so yes, they are like terms, and we can add them. We can also subtract them same way, right? So 2p minus p is going to be simply p. All right, so if we have the same letters that don't matter, if we have the same letter, different numbers, that doesn't matter as well. They're still like terms. All right. Um, all right, so let's look at something else. So let's say,
Okay. Um,
yes, someone have a question?
how does it get 2p? I mean 3p.
Okay, because here we have p, right? And this p, and that's a very good question. Once it's 1p, because it's only 1p, like once it's just p, there's the coefficient in front of it is actually 1. So even though we don't write it, it's actually 1p plus 2p. And 1p plus 2p is 3p. But we don't write the 1. Even though it is still true, the imaginary 1 is there. We don't write it. Okay. So that's why it is 3p, because we have 1p and 2p, so that's 3p. So then there's that. The next thing we have is, let's say we have, say, 3h and 5h. Okay. So the question is, this one is for Deja. Are these like terms or not?
They are.
Okay, so you say yes. Why would you say?
Because they have the same variable.
Okay, same variable. Um, even though they have different letters, I mean different numbers in front of them.
So once it have the same variable, you could do the opposite operation in both of them.
Excellent. So same letter, different numbers in front, doesn't matter. All right, so that's important. So we can add these variables together. I mean, not variables, but add these terms together. So 3h plus 5h Kc. What is 3h plus 5h? It's going to be what?
AH.
8h. Excellent. Good. Next up. This one is for Jasmine. So Jasmine, what if I have 2.4 Q and 5.6 Q? Are they like terms? If so,
Like
say
term.
it again.
Like term.
Yes. Okay. Why would you say?
That's the same letter.
Same letter. Even though it's decimal? Even though decimal in front?
Oh yeah.
Okay, good. So yes, you're right. Same letter, different decimal numbers in front, doesn't matter. So yes, these are still like terms. So this will be 2.4q and 5.6q still like terms. And what is 2.4q plus 5.6q? This is going to be for Jasmine. What do you think, Jasmine? Jasmine, 2.4q plus 5.6q.
Got it.
2.4q plus 5.6q. What would I give us?
80Q.
Say 80? 80? Well, okay, let's look at it. 5.6, 2.4. 6 plus 4 is 10. 5 plus 1 is 6. 6 plus 2 is 8. So it's actually 8.0. I mean, know that 8.0
Oh.
is the same thing as 8. Because 8.0 is 8. It's like $8.50, which is still $8. So it's gonna be 8q. Right, so yes, this is still like terms. So 8q. Alright, so same letter, different number, different decimal in front, that doesn't matter at all. So let me clear that term still. Alright, so moving right along. Okay, what if I have, this one is for, this one is for Rashan. Let's say we have, say, so let's say we have, so let's say we have 1 over 6. Let's say that's 1 over 6 m. And let's say we have 3 over 6 m. My question is, Miss Rashan, are these like terms or not?
Yes, sir.
Okay. So the fraction doesn't matter in front. Is that what you're saying?
Yes, sir. And it also has the same denominator.
Oh, you have the same denominator. All right, having the same denominator is good, but that doesn't tell us about them being the same like terms. But like we said,
You have same letter.
yeah, the same letter. Yeah, that's what makes the difference as well. Same letter, different, let's say, fractions. Doesn't matter. So what if I were to add these two fractions? What would I get?
4 over 6.
4 over 6. 4 over 6 what?
4 over 6 m.
4 over 6 m. We can't forget our part. It's gonna be 4 over 6 m. Okay, pretty decent. So the reason why is because we add the numerator 3 and 1 is 4 and the 6 stays the same. Okay. So we have seen that, hey, I don't like all this. We have seen that, hey, if if we have, the same letter with no coefficient except the imaginary coefficient of 1, it's still like terms, just same letter, it's fine. If we have one with that has if we have a term that has where its coefficient is not visible, like p, and we have one where it is visible and the numbers in front are different, then it's still like terms and we can add them. If we have where the numbers in front are different, as in 3h and 5h, it's still like terms. If we have where the decimals are different but the letters are the same, it's still like terms. And even if we have where the even if we have where the fractions are different, these are still like terms. Alright, let me this is sort of a challenge one.
Excuse me.
Yes, ma'am.
You gonna give us questions on these?
Yes, ma'am.
Okay.
Alright, so this one is sort of a challenge, not extremely difficult, but interesting. So what if I say, what if I say that what if I say pi b and say 2 over 6, or let's say 2 over 7 b, are these still like terms? Anyone could answer.
Yes, so they are like terms.
Think they're like
No,
terms?
so I agree.
You agree? So I
They're
heard someone
like
say
terms.
I heard someone say
They're like
no. Go ahead.
they are like terms because they have the same letter.
Alright, but the person who said no, who was that? Do you wanna stand on that, or you wanna say, you know what? I think it's still right. Well, we have pi b and 2 over 7 b, and yes, they are still like terms because it's the same letter, and um, it's the letter that counts, not what's in front. Right? And if we were to actually add these two, pi b and 2 over 7 b, obviously our answer wouldn't be a rational number or rational expression, but we'll leave it like that. I don't want to simplify this because what we eventually have to do with this, if we're trying to simplify it, we would factorize it and then focus on the constants. So we're essentially dealing with pi and 2 over 7, which, unless you have a calculator, you can't really do unless you leave it as pi plus 2 over 7, or you write it as a decimal.
I have a question.
Uh-huh.
So why we can't just do 22 over 7, right? Isn't that another way for that? Isn't that a fraction version of pi?
Well, that's the thing. You familiar with rational and irrational numbers? Are you familiar with those terms?
Rational, irrational, yes sir.
Okay, good. So what is an irrational number?
Uh, a rational number. It in my research, correct, I don't think irrational numbers have an ending.
Okay, they don't have
They just keep on going.
exactly. And another characteristic of irrational numbers is that by definition an irrational number cannot be represented as a fraction. Okay, so always remember that. An irrational number cannot be represented as a regular fraction. So pi is an irrational number. And so pi cannot be represented as a fraction. And so you may ask, okay, well, what about 22 over 7? 22 over 7 is not exactly pi. 22 over 7 is an approximation for pi. All right? And so, no, we can't use 22 over 7 or change pi into 22 over 7 because it would be an approximation. Or it wouldn't be an exact value. Because pi, as an irrational number, cannot be written as a fraction, a proper fraction. All right? So, that's the thing.
Excuse me,
Go ahead.
that's a 2, not 22.
Yeah, and that's true. It did say 2 and not 22. But she's thinking about pi and how pi is sometimes represented as 22 over 7. But yeah, 22 over 7 is not exactly pi, it's an approximation. Right? Alright, so okay. But what about this one? Right? So let's see.
So the answers stay the same?
Yeah, we'll just leave it like that. We won't simplify it at this level yet. We won't bother. At least I won't bother to move on. It just I don't want to bother to do that right now. Because we just need a calculator to do it. And the assumption is that we're not using calculators at this time. Okay, so what if I have x and x squared? So this one is for Albernic. X and x squared. Do you believe that they are like terms?
Yes, sir.
Alright. The answer is actually no. Okay. They are not like terms. Interestingly enough, right?
Because it's a square.
Yeah, yeah. Because of the power. So they are not like terms because even though they have the same letter, they do not have the same power. So this one is x to the power of 1, this one is x to the power of 2. They are unlike terms. Remember, for unlike terms, we can't do nothing with it. So we cannot perform operation. So we can't add or subtract. We could multiply it, but we can't add or subtract. All right. So yeah, so no. So that's interesting to remember. X and x squared, they are unlike terms. Okay, because even though they have the same letter, they don't have the same power. So be careful of that. And then we have, say we have a and a to the third power. This one is for Altwinic, right? Are these like terms? A and
That is not a like term.
not a like term. Excellent. And it's not a like term because of the same reason. They have the same letter, but they don't have the same power. So that's better than mine as well. What if we have, say, what if we have y to the second power plus 2 y to the second power. Are these like terms, Sierra?
Yes, they are.
Yes. Y.
They have the same power and letter.
Very good. So same letter and power. And so that would mean that if we were to add them, Sierra, what would we get? Y squared plus 2y squared.
So that would be 3y squared.
Exactly, 3y squared.
How you get that?
Okay, because if you look carefully, this is, oh, I cannot perform operation. So this is 1y squared, and this is 2y squared. So 1y squared plus 2y squared is 3y squared. Like I said,
But it have
go ahead.
but it have a two on top and the don't have a two.
Say it again.
I because it have a two on top and the don't have a two.
Okay, so what you expect it to be?
Put 2 plus 2 plus 2.
All right, good question. Good thing. Look, with the like terms, we keep the like terms constant. So y squared, we do not involve these into our addition. The only thing that we worry about in the addition is this one that's in front and this 2 that is out front. Only these two we are concerned with. Okay, we're not concerned with the y squared and the y squared. The y squared, we put that automatically back. The only thing we concern ourselves with is 1 and 2. So that's a good question. We only concern ourselves with the coefficients. Right, so to give you another example, if we have, say, that's a very good question. I would have never thought about that question. So let's say we have, instead of y squared, let's say we have h. Let's say that this is 4. Let's say that this is 5. And so, Albernic, what would be the result of adding these two?
A 9 to the power of 2.
Say it again.
9h to the power of 2.
Excellent. So it's going to be 9h to the power of 2. Alright, so you only concern yourself with the numbers in front. Right, so 4 in this case and 5 in this case. So 4 and 5, that's 9. 8 squared, we don't add them or nothing. We just keep the 8 squared. So, yes, because it's the same letter and power. Alright, so be careful of that. What if we have, say, 5 so we have 5 n to the 4th power, 5 n to the 3rd power. Okay, this one is for Altonic. Are they like terms?
Yes,
Yeah? Ciara, what do you think?
They are like terms, but they don't have the same power.
What?
So that'll be okay. So it's not a like term because of the power.
Exactly. So no, we don't mind the same numbers, don't let the numbers trick you. We don't worry about the numbers. All right. We're only concerned about the powers. So this is n to the fourth power. This is n to the third power. So these are not like terms because they have the same letter, but not the same power. This one is to the power of 4, that one is to the power of 3. So we cannot perform the operation. So hopefully you understand how tricky this could be, right? You have to be careful. At any point, at any time, we can throw something at you. And you might say, oh, let's add them, oh, let's subtract them. But you got to be careful and make sure they are like terms first. All right. Obviously I can't show you every example that's in the book, right? Or every example that's in, when I say in the book, or every example that's in the world, of course, I can't show you every example. But hopefully this serves as a good rule of thumb that when you are looking for like terms, you are considering the letter and the power. That's the only thing you're saying in your mind. What is the letter? What is the power? Are they the same? And I almost forgot the most trivial example, eh? How could I forget the most trivial example? I doing all these complicated stuff and I forget the most simple of them all, right? This is the one that you probably might be seeing more often than not. So if we have, yeah, I can't forget these examples. These are the tried and true examples. So I must include them, even though they're more simple. So A plus B, this one is for Deja, like terms or not.
Um. Uh. Well, this is unlike. At least I think it's unlike. They have different variables but same coefficients. They both have one in the front of them, but they're different variables. So it's unlike.
Excellent, unlike. I was trying to find a finger with why you taking so long, Dan. So,
Because
okay.
I saw this on the SAT past paper, right? Because I have like a booklet with some SAT past papers. I
Uh-huh.
saw like questions like this, and they expect you to answer it. I was so lost. Like this
Ah.
different terms, like what you want me to do with it?
uh, I'm sure they give you some more information than that. I am certain. Um. So, so no, they are not like terms because they are not the same letters. Okay, so that's important. So we cannot perform addition or subtraction. We leave it like that. Insert rows below. So let's do another one. This one is for Jasmine. Let's say we have, say, 2x plus 3y. Are they like terms? Yes or no? Jasmine?
No.
No. Excellent. They are not like terms because
Different numbers and letters.
numbers and letters. But what's most important? What's the only thing that's important when we looking at like terms?
Pardon?
What's the only thing that's important when we looking at like terms? The numbers or the letters?
The letters.
The letters. Very good. So that's the only thing we're concerned about. So are not the same letters. This way, so we can't perform the operation with those. It's an interesting one that I'm gonna give you. They just come into me as I think, and so I'm glad that I am able to think about them before we actually get into the exercises, so that you can have a good glimpse of what's happening here. So let's say we have 3 AB plus, not plus, but oh my goodness, I don't know why. Okay, well I have the addition between them. So let's say we have 3 AB. I realize that I changed my format. I start adding them first. Interesting. Well, still works. So 4AB. So my question is, this one is for KC. Are these two like terms?
Yes, sir.
Yes. Okay. Why is
Yes, sir.
why is it a like terms?
Because they have the same letters.
Exactly. Very good. So they have the same letters. I'm surprised you got it. Right? Same letters. So even though, see, this one have AB and this one also have AB. So they are the same variables. All right. So definitely they are like terms and we get to perform the operation. So what would be the operation here if we were to do it, Casey?
7 AB.
7AB, very good. 7AB, excellent. I kind of liking this table. This table is a very rigorous table. I like this table. Very comprehensive. I like things like this. You get to see it. I put like terms examples. I was supposed to put like and unlike terms, right? Examples. Yeah, you might think I'm looking at a book, but these are just coming from, what comes to my mind right now. And so I like that we can construct a nice, neat table on the fly. That's good. Okay, so what else could you think about? There are different ones. For example, it's probably gonna be the last one that I include, unless there's a really more important one that's, bigger than this one that needs to be included. So let's say we have 5. This might show you, what's the true difference. So say we have 2AB and say we have 4ABC. Not 4, let's say 6. The question is, are these like terms, yes or no? This one goes to Rashan. So you have 2AB and 6ABC. Rashan, do you think that they are like terms or no? Rashan, Lily, where are you? Alright, I'm not hearing from Rashan, so I'm gonna go back up to Albanic. Do you think that these are like terms, Albanic?
They are not like terms
They are not like terms. Very good. Why?
because of the letters. Because 2AB and 6ABC, and they're not the same letters.
Yeah, different letters, right? Or we can say, yeah, different letters. So we cannot perform addition or subtraction with these unlike terms. And so no, we can't. Alright, so now it's time for our practice problems. I am going to use a book for these practice problems, and it's a nice and easy book because you know they ain't like my questions. My questions are a little more interesting than these, but I see someone clap their hand. I don't know what that's supposed to mean. uh, but nonetheless, let's continue. I have one more thing to add. That let me save this. We can call this. Guess we could call this like and unlike terms. Hey, this is the comprehensive version. I really like this. What we did today with just explaining it and seeing it through like this. It's really nice to me. I like to see stuff like this, expanding it out properly, right? Seeing a clear overview. That's why I'm glad that these classes are like 2-3 hours long, so we get enough time to actually see everything properly in a more rigorous way, right? I really like stuff like that. So I hope you do too. I really do. Nonetheless, like it or not. Oh, I did say that there's one more thing that we need to add, right? And nobody even remind me. There's one more thing we need to add to this thing. And it's this. So remember, and this is something that you have to remember. We call it directed numbers. And to be honest, I think that directed numbers, directed numbers, like how to add and subtract. What I mean is, what do you do when you're adding a negative number? You know, what do you do when you add in two negative numbers, adding two positive numbers, adding a negative and a positive? That is something that comes up a lot. So I think that's a prerequisite skill for this. And that idea comes up a lot. So that's important. Yeah, that's important. Remember also, so I just want to keep this in mind because, like I said, it's a prerequisite skill. Remember also that subtracting is what the book is saying, and I think that they are very right to put this in there. Subtracting a negative number has the same effect as adding a positive number. So for example, and this is something that we definitely need to cover. We have negative minus 2. That equals what? So we have negative minus 2. What is that? Anyone can answer. You don't be shy. Negative minus 2.
What?
What? What is that? Negative minus 2. What is
Wouldn't it
that?
be positive too?
Yes, positive 2. Thank you, Miss Deja. So it's positive 2. You don't have to guess about that. And what if we
I
have?
have a question.
Go ahead.
So when you say subtracting a negative number has the same effect as adding a positive number, you mean it like how? Because I don't understand that. But you mean like how teachers be like, if you have a negative and a positive, you subtract it, decide a bigger number, and stuff like that. Or if you have two negative numbers, add and keep the sign.
All right. So what I'm talking about here, this could be phrased another way. Because I thought about it, I'm like, you know what? The way how they put it is weird. But all it means is that a negative multiplied by a negative gives a positive, right? So here we have negative and negative, that it gives us a positive. But the brackets mean multiplication. So essentially what we have is negative multiplied by negative, and that gives us positive 2. All right, so that's important. That's what we mean, Deja. So again, negative multiplied by negative 3. Who could I ask? Albernique. What is this? Negative 3 multiplied by negative. Sorry, negative multiplied by negative 3. Gives us a what?
It's a positive 3
Positive 3. Good.
equals 3.
Yeah, excellent. And then finally, if we have a negative, so that's for 20, negative 6. Negative 6 equals what?
A positive 6.
Excellent. I like that energy.
And then it equals 6.
Excellent. All right. Wow. Y'all come with a lot of energy in this class. That's good. Okay, so now let's do it. Now let's get into, I guess, the drama or the excite or the torture, or I don't know, whatever you would like to call it. Or the fun. I don't know. However you have in mind. Whatever it is, but let's just do it like that brand says, right? So practice, practice makes perfect. Once it's perfect, practice, eh? So let's simplify these expressions. You think about the greats, call them the greatest of all time, right? The greatest swimmers of all time, the greatest runners of all time, the greatest NBA players of all time. For those who watch the SPs, you would know what I'm talking about. They had to sacrifice, right? They had to practice a lot. Some of them start since they were 6 years old, 5 years old, perfecting their craft, right? And so it's the same thing like us in our domain, whether it be mathematics, whether it be language, right? We have to practice and we have to get better at what we do so that we too can excel like how they excel in their area. And trust me, they're doing very well in their respective areas. And so look at them, they're good inspiration for you as young ones, and even for me. That's a little older than you all, as you can tell from my voice. I am not much older than you, but I'm a little older than you, and so even for me, looking at what they have done is a good source of motivation, and it can encourage you too to give your best at what you do. So as we do these exercises, even though you might not want to do it,
The
yes, ma'am.
topic, I mean, not topic, the process supposed to be simplified.
Simplify, yes. Simplify. Thank you so much. I did it on purpose. I was just testing you on, make sure you're focused and uh, make sure you're there. Nah, that was a mistake. Thank you so much. Simplify where possible. So A plus B plus C. All right, number 3. So we're gonna practice. We're gonna do our reps, like they say, so that we can get better at what we do, so that we can also excel in our areas and be able to live productive lives, right? By God's grace. So, all right, so give it everything you have. On number 4, these questions look nice. They're pretty. I mean, Depends on what you define as pretty, but they're okay. Oh wow, there's one thing I forgot to give you in the practice there's one thing I forgot to give you. But anyway, hopefully we can see it out. Yeah, we didn't talk about constants in our discourse, so that's gonna come up anyway, so I'm hopefully ready for that. So a squared plus a
Pardon?
plus 1. There's something I forgot to give you in the exercises, but I still think that you could be able to answer these questions without it. 5c minus 4c minus 3c. And number 6 is going to be x plus y, sorry, x plus 4y minus 3x4 plus 3x plus 5 plus 6x. Number 8 5x minus 2x. Number 9 3p minus 4p. Number 10 3b minus 7b plus 4b. Alright, so there we have it. Those are your 10 questions. How much minutes should I give you all? How much minutes should I give you? Nobody's saying nothing. So I guess I should just give you 1 minute. Call it a wrap.
Don't give us 1 minute, yeah. Just give like 2 minutes, yeah.
2? Okay, alright then. Alright then, per request of Albernic, we're going to give you 2 minutes. The 2 minutes have begun, and the timer is going. Do your best. You know, that's all I can ask from you. Do your best. Do the best that you can. And on the other side, we would see exactly how did you do. Okay? You know, there's a lot of numbers and letters. It's algebra, right? And so hopefully you're able to do it. Less than 1 minute and 30 seconds left.
Excuse me. For number 10. For number 10. That's supposed to be 7B or 7-6.
That's 7b, negative 7b. All right, that's time. So let's tackle these questions. I have to begin with Al Bernick. We're gonna look at question number 1.
Okay, for my answer, I got 12x.
You got 12x. Okay, so we know that 3x plus 4x, that's 7. And 7 plus 5, 7, 8, 9, 10, 11, 12. That's correct. It's absolutely right. 12x. The next one goes to Altonique. What is A plus B plus C?
D. Is it D?
D. Interesting. That's funny. You sure? That's an interesting answer. I wasn't expecting that. But I understand why
What
you
she
would say
say?
that. She says D. You know, we got A, we got B, we got C. So
I know
The
what
letter
it is.
D?
yeah, the letter D. Yeah. So that's
I know what
Honestly,
it is.
at least she came up with something.
yeah, that's interesting. I was not expecting that answer. Jasmine has a hand up, so I'm gonna let Jasmine
ABC.
A B C. Ah, it's exactly it's the same thing, right? So we can write cannot be simplified. So it's Altonic. It's not D, even though I can understand why you would say that. And that's a interesting answer. I never thought about that. But it can't be simplified because the terms are unlike terms. So we leave them as such. Unlike terms, we can't simplify them. All right, next up would be Sierra. What's up?
I don't think that could be simplified, but I also got an answer, if that makes sense.
Oh, okay.
I got 12. I got 12A.
12A. How did you get 12A?
Okay. So I did 2A.
Mm-hmm.
You gotta subtract. That's why I don't think she subtract.
You think she subtract?
I did 2A. What did I do? I did 2 A, I think times 3A plus 7.
And I guess you add the 7 and the 3 and the 12 and the 2.
Yeah. With
Is that right? Anyone could help out? Is that right? She
I
adds
have 8. I have 80.
You have
I don't
8
know
A.
why.
Okay. Interesting. Alright, so Deja, what you got?
I have 5A plus 7.
5A plus 7. Okay, so all of us have different answers. Okay, so
Wow.
alright, so the first thing is, remember I showed you that initially that these two, we have a negative times a negative, and so immediately we would change that into a what?
We will change it into a positive.
Positive, yeah. So positive 3A plus 7. Now the thing about this is that the only like terms we have are 2A and 3A, because 7 is not a like term with these ones. Okay, Sierra?
Okay.
Yeah, 7 is not a like term with these. 7 is a constant. So so 2A and 3A, we have to add them together, so it's going to be 5A. And we leave the 7 by itself, so it's going to be plus 7. And so that is important there. So it's 5A plus 7. And that's why I said in my remarks, I said, you know what, there's something that I forgot to include. A very important one. It's not trivial, it's very important. And so let me put it here. This one where we have, well, let me insert it below. If we have, say, 7 and 9, we would say that these are like terms because, well, 7 and 9 are constants, and so 9 plus 7, that's 16. So yes, these are like terms because numbers with numbers, and we could call them, we actually call them constants, right? Constants with constants are like terms, right? So numbers with numbers are like terms, but when you have a number, where we insert this below. So when you have a number with a letter, so say 5A and say 7, and we try to add them, we can't. So this is no, because numbers and letters are not like terms. So we can't perform addition or subtraction with them. Alright, so be careful with that. 7A plus 5A plus 7, we can't perform the operation. They're not like terms. So be careful with that. So that was the only one that I feel like I needed to add to that list. Now I think we really have an exhaustive list now. I think that our list is pretty much, heavy. Alright, so moving right along. So that was needed. Sorry. Next up, we have, this one is for Deja. A squared plus A plus 1. What is that?
I just put the same thing back.
Okay, so cannot be simplified.
I mean, because A squared is a different term from A,
Uh-huh.
and 1 is a different term from both A's. So
Very
you couldn't
good.
really go nowhere with that.
Excellent. So you can't do nothing with that, so it cannot be simplified. Or if you just write the same thing back again, that's fine. All right. This one is for Jasmine. What are we gonna do with this one? It's a nice one.
I get 12D. I don't know what that.
The 12T, okay. So we know a negative times a negative is going to be
A positive.
Positive.
positive. So 5T plus 4T minus 3T. Order of operation tells us that, hey, we do addition first, because we always start from left to right when it comes
I
to.
thought that the minus 3T was a thing a negative. Just that.
Okay, okay.
I don't know what the
Yeah, there's subtraction. And so this is gonna be 5T plus 4T, which is
90,
9T, yeah. So it's 9T
16.
minus 3T. Very good. That's gonna be equal to 60. Good. And this next one is for Casey. How do we do this one? X plus 4y minus 3x.
X, take away 3x plus 4y.
Okay, very good. I like that you did that. The first thing we do is we group the like terms. So this is like with this. Very good observation. So x minus 3x plus 4y. Very good. Good. What do we do after this?
2x.
Okay, so x minus 3x is negative 2x.
2x
And it's
plus
important,
4y.
before we move, right, it's important to know that this is a negative 2x because this is x minus 3x. So it's as if you have 1 minus 3. Okay, and so say you have $1, but you owe someone $3. And so that means that when you pay them back the dollar that you owe them, you still owe them $2. And so it's negative 2x plus 4y. So that's good. Excellent. Next up we have 4 plus 3x plus 5 plus 6x. And so what is that? This one is for what's her name? Rashan.
Okay. So it could be simplified
Go ahead.
because
Go ahead.
it have 4 plus 3x plus 5 plus 6x. So all you basically doing is adding, and the letters both the same. So once you add all the numbers together, the letters still be same.
Okay, so what's your answers?
One minute.
1 minute, okay. I like Rashan, 1 minute pause. She's gonna hear that. Okay, 1 minute. I just gave you all 2 minutes. Like, so that's interesting. So we're waiting on Rashan. Do we have 4 plus 3x plus 5?
18x.
Okay, so you think we're gonna add all of them? Let me ask a question. When it comes to 4 and 3x, are they like terms? 4 and 3x?
Yes. No, sir. Because they don't have the x.
Yeah, they don't have the x, right? So which one are like terms?
6x and 3x.
Good.
And 4 and 5.
So we're gonna like terms and put them together. So 3x and like you said, the 4, 5. We have 3 is 9x, and interestingly enough, 4 plus 5 is 9. So we end up having 9x plus 9. Interesting. Interesting there. Okay, so the last two, these 8 and 9, we scale down, so it should be easy. This one is for Al-Tuanik. What is 5x minus 2x? Say it again.
7x.
5x minus 2x. So we subtract.
Oh. 3x.
Excellent. 3x. Good. Excellent. And then Al-Bernik. 3p minus 4p.
1p.
No. 3p minus 4p. So 3 minus 4. So you have $3. You owe someone $4. Pay them back the $3 that you owe them. You still owe them $1.
Again, -1.
Yeah, -1. So that's very good. And so that's -1p. Or we could simply write -p. So be careful of that. So we don't have 4 minus 3, because 4 minus 3 definitely is 1. But we have 3 minus 4. So that's a bit different. Yeah, I think that we really need a class on directed numbers, because that keeps on coming up on. And we have a lot of problems when it comes to directed numbers. So this one is going to be for Sierra. What is our answer for this one?
0B. Right? I guess 0B.
You asking me or you telling me? Which one?
I'm telling you.
You're telling me. Okay, she's saying, Mr. Petit, you ain't gonna fool me this time. All right, let's see. So, like my teachers say, there's different ways to skin a cat. So, all of them are like terms. So, 3b minus 7b plus 4b, all of them are like terms, so we can perform our operation. So let's begin with the subtraction. So
Again, -8.
someone say they get -8. Well, we have 3b minus 7b, and so it's going to be -4b. And the reason that's the case is because it's 3b minus 7b. So you have $3, you owe someone 7, you pay them back the $3 that you owe them, and you still owe them $4 because you did owe them 7 originally, plus 4b. And this is interesting because you have $4, you owe someone $4. Pay them the $4 that you owe them, and how much money you have left. How much money you have left after you pay them the $4 you owe them?
0.
Yes, 0. You have $0 left because you gave them all the money you had. So that's 0B. But 0B is simply what?
B.
B.
B?
I don't understand this already.
Someone said they don't understand the 0. Okay, so
0.
all right. So let's say, for example, you have positive, 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 and positive, right? So that's the 4 positive you have. And you have negative, 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 and negative. Good. So let's do some cancellation now. This one would cross over with that one. That one would cross with that one. That one cross with that one. Cross over with that one. So how much you have left? Nothing. 0. So you're left with 0B. Now 0 times B is what?
0.
Yes, 0. And that's because 0 is what we call the not the additive identity. That's a word that we use for 0 that
Whole number.
no, not whole number.
Neutral.
It's not neutral. That's the 0 property. So the 0 property tells us that once you multiply 0 by any number, you get 0 in return. So 0 times 1 is 0, 0 times 3 is 0, 0 times 4 is 0, 0 times 5 is 0, 2 times 6 is 0, 0 times 2000 is 0. Right? That's the 0 property. And we have to learn those properties. You know, you have the commutative, distributive, associative property that we have, and also the 0 property, and the inverse properties, and the identity properties. Those are good properties to know. So 0 times 0B equals 0. And then we're done with those 10 practice problems, which was a good set of 10, I would say. It helps us to at least start with the good foundation, and that's what I like about these questions. It really gives us good foundation. Obviously, there's not every question in the world that I could possibly ask you, but hey, it's a good start, right? So that's good, and I can live with that. I can live with a good start. All right, so any questions on this particular concept?
So we just supposed to like ignore the 7B and the 3B.
Say it again.
Supposed to ignore the 3B and the 7B and just put 4B.
No, that's not right. That's not right. You have to include them, because all of them are like terms. You have to perform the operation between them. So 3B minus 7B. Or you could do, 3B minus 7B, which is negative 4B. And then add 4B to negative 4B. So that's 0B, and that's 0. So you have to include that. Alright. Hopefully there are no questions. If there are, please let them be known. If you have any questions on what we just covered. But that was like and unlike terms, right? I think I should put that in the section, right? So like and unlike terms. That was really the the highlight, let's see. There's also something else, right? So we still on section 1 with simplifying algebraic expressions. Maybe we'll call this section 1.1, right? And then we're going to move on to section 1.2, which is this one. The emphasis was, like and unlike terms. And we had restrictions, right, when it came to like and unlike terms. Like, okay, you can't add and subtract unlike terms. Like that's a no, right? That was the restriction, right? But yeah, it becomes different because with this one, with section 1.2, we would find that when it comes to unlike terms with multiplication and division, there are no such rules. We could do whatever we want to do when we are adding and subtracting. Sorry, when we are multiplying and dividing unlike terms. Okay, so that's interesting, right? And so I think we should begin with the remark. In particular. So section 1.2, simplifying algebraic expressions, like and unlike terms. Let's put the emphasis on multiplication and division. And for this one, the emphasis was really, addition and subtraction. So, we have that rule that we can't touch it if they are unlike terms. We have to leave it. But that only applies for adding and subtracting these things, right? When it's time to multiply and divide, we can do whatever we feel like. So let's begin with the remark. If we have like terms, or even if we have unlike terms, we can multiply and divide these terms with no problem, right? So that's important. I hate to say divide because technically you can't really divide 7b by b, technically speaking. So it only really works for multiplication. You can multiply them, and even still, there's still it's only so much you could do, right? There's only so much you could do. Let me make the remark. But even this is limited, right? So you can't divide and multiply freely or how we regularly do it. But unlike with adding and subtracting, where we had a restriction, say, right, on combining them together or bringing them together close. There's no such restriction with multiplication and division, right? Yeah. I even hate how I express this. We still technically can't multiply unlike terms in a sense, right? We still are limited with that fact, but at least with adding, at least with the multiplication and division of unlike terms, we can bring them close together. You know, we can bring them closer, which addition and subtraction just wouldn't allow us to do. So here's what I mean. So say for example we have uh, say for example we have x. I hate to use x, because x is hard to understand at first because it looks so much to the multiplication sign. But let's say we have a times a, right? So obviously we would say these are like or unlike terms.
Alike.
They are like terms, right? So according to the rules that we have constructed, or we have said that, hey, for addition and subtraction that works. For multiplication it sure works as well. And yeah, we can just say this is going to be what? A times a is what?
A squared.
A squared, right? So yeah, for like terms it works, but watch this, right? This is where the distinction happens. So say for example we have, say, b to the power, b times, say, b squared. Now, are these like terms, b and b squared? Are they like terms?
No, sir, but we still could multiply them, right?
Yeah, no, but we still can multiply them. So even though they are not unlike terms, we don't care. This is multiplication we're talking about. We can put them together. We can bring them closer. And we can actually, do some good multiplication here. So b times b squared, can someone tell me what that would be? B times b squared, what is that?
B3.
B to the power of 3. B to the third power. Alright? And I want you to speak the language of mathematics. You don't have to be afraid. B to the third power, right? Say that with courage and passion, you know. B to the third power. We know that, right? Because we were taught it, right? It's cool. Ah, this is nice. I like how it flows like that and they don't have to be so, you know, bulgy. Ah, okay, cool. So if we have it like this, does that say space and sense? I guess it kind of does. Okay, pretty cool. Alright, so here's the thing, right? So these are like terms, and multiplication works, right? And on the other hand, these are, we'd say, unlike terms, right? And multiplication still works. Someone have a question for me. Sorry, Miss Diana, what did I miss? Nathan. Yeah, I don't know exactly where you came out, so I'll send you the notes from this file. Just begin writing from where you're able to, and I'll send you the file to write the rest. So that's interesting, right? Unlike terms and multiplication still works. That's crazy, right? Yeah, it still works, right? Okay, let's look at something else. So say for example, we have, say, like someone said today, which was hilarious and certainly a wonderful thing. They said, how about D? Right? You're talking about A, B, C. Well, how about D? And that was interesting. And so we're gonna use, in honor of that joke, we're gonna use D Let's alternate. We're going to use D for you. And let's see. If we have D squared times D to the fourth power, what is that going to be? Anyone could answer?
D to the power of 8.
D to the power of 8? No. Remember, this is application of... Anyone remember what rule this is? This is exponential. This application of which rule? Someone said it?
Quotient?
Not quotient, because we deal with multiplication.
Product.
Say it again.
Product.
Product rule, excellent. And so, if we have the same base when we're multiplying, we add the powers. So what's this going to be?
8?
D to the
No.
power of... Not 8.
6.
Exactly. 4 plus 2, which is D to the power of 6. Alright, so that's important. Alright. So again, unlike terms. These are unlike terms, but yet multiplication still works here. And so that's interesting. But let me show you a different, right? So let's say, for example, we have, say, I know we would like to think that multiplication works, but let's say we have A and say B, right? So what would that be? A times B. How do we write that?
AB.
AB, very good, AB. So, they're unlike terms. Does multiplication still work? It kind of works, right? It's cringy, right? Like, ain't like we have a power, extra power, something like that. But at least they're together, right? At least they're close, right? It's better than addition. Addition is like stand off, don't come near me, right? Just stay. But at least it's close, yet limited, right? So it's still limited in a sense. So we can't really merge them really into one term, but we can do our best, right? We have something sensible there, AB. Hey, kudos. So yeah, that's what we mean by limited. Um, so what if we have, say, all the examples here are with multiplication. Didn't really touch division. That's interesting.
Pardon?
No, not you, not you. It seems like I have to make up my own for division. Let's just keep it for multiplication for the night. I'm not really gonna work up division. We've run out of time, so we could deal with division at a later date. So let's start adding some coefficients here to make this thing interesting, right? So let's say we have 7, say we have 7, P times 2 R, right? So what would that be? Anyone? 7P times 2R.
14 PR.
14PR, so 14PR or 14RP. So they're unlike terms, yet multiplication still works. It's limited, but it still works. All right. Yeah. So those are good examples of what we could do. Remember that multiplication by like signs gives a positive. So that means that if we have positive times positive, that gives us a what? Positive times positive is a
Positive.
positive, yes. And CR negative times negative gives me what?
Give us a positive.
Give me still a positive. Okay, so that's interesting, right? So the idea is that, you know, if they're the same sign, it's a positive, right? Like signs give positive, right? So that's interesting. So example of obviously would be, you know, say, let me just put it here so that you can see it one time. If we have, you know, 2m times say 4m, that's gonna be equal to 4 times 2 is 8. 8 what?
8m.
8m squared. So let's be careful because multiply the 2 by the 4, that gives you the 8. But the m and the m is m squared. So that's something. So positive and positive, still positive. But if we say, even if we say negative 2 and we say negative 4, only that elongated negative. So let's read it back. Let's go. So go ahead,
Excuse me,
Mike.
sir. How can we get a square? How do we get a square?
How do we get a square? All right. So what is a times a?
64.
No, not not 8 times 8. A times a.
What?
What is
8 times
a times a?
8 times 8 is 8. 8 to the power of 2.
Good. So what is m times m?
M times m is n to the power of 2.
Yeah, that's how we get it.
Oh,
It's like how a times a is a squared, m times m is m squared. And similarly, and so therefore 2 times 4, or I should say in the same token, 2 times 4 is 8. And notice negative 2 times negative 4 is still positive 8. So like we said, multiplication by signs that are the same give me a positive. But multiplication by signs that are different gives us a problem. So remember that multiplication by unlike signs gives us a negative. So like terms, sorry, like signs, positive. Unlike signs, negative. So for example, if we have a positive times a negative, right? So we have a positive times a negative. What should that give us? Positive times a negative.
Negative.
That should give us a negative. Very good. And if we have, what if we have a negative times a positive?
Negative.
Excellent. So that should tell you something, right? So if you are positive and your friend is negative, the chances of your friend converting you to the negative side is more likely. Just saying, in general, right? Um,
For
just
those
like,
who have friends.
yeah, for those who are friends, right? I hope you are friends. That's what normal people. Anyway, yeah. So positive times negative is a negative. Um, and negative times a positive is a negative. Sometimes it's hard to have. I understand what you mean, teacher. Sometimes it's hard to have, you know, tight friends because you're like, you're going this way and I'm going this way. I don't think we are, you know, I don't think we are actually seeing eye to eye because you want to do this and I want to do something more productive. And so sometimes it's just best to let them go. Um, for those who do have friends, try to make sure that your friends are positive because positive and a positive gives us a positive. But a positive and a negative gives us a negative. So if you're negative and your friend is positive, yeah, you might end up changing your friend to the negative side. But this one is interesting and funny. Negative times a negative is a positive. That's funny. I don't think that works. I mean, you don't want to be a negative and have a negative friend. That's just not good. So let's stick for positive and positive. The ideal, right? All right, so let's see how it is in math, right? So what do we mean? So if I have a -2, it's positive 2. So if I have the +2 and a -4, that should give me a what?
A -8.
Yeah, that should give me -8. Excellent. And then if I have a -2 and a +4, what should that give me? -8 squared. So those are the rules to remember. We actually done for math today, interestingly enough. I think that was a full session for math. So we covered, the fundamentals of like and unlike terms, really, grasping that in the true sense, you know, getting a comprehensive look at that. And then we said, you know what, well, that's unlike terms for addition and subtraction. What about multiplication and division? And we saw that, hey, for multiplication and division, in particular multiplication, yeah, it works. Even if you have unlike terms, it works. Even for like terms, it works the same way. But that is limited. And so we saw where it could work perfectly and where it's limited. And we ended with just a word of caution that, hey, like signs, positive. Unlike signs, negative. And so with that being said, we end format. We're gonna move over or transition over to language. And for language, we are continuing in the same essay. We haven't finished that yet. We're still diving into that, chewing it and developing some principles with that. And so the last thing we did for language, anyone can remember, was what? The
We
last thing
talked about rebuttal.
we talked about rebuttals. Tell me one thing about rebuttals that you remember last night. At least something that stood out to you.
That it brings a sense to your closure. Your position. It brings a sense to it brings a closure to your position. Like where you stand, like if you disagree or agree. You know what I mean?
I hear you. Um, Break it down for me some more. I don't think you're using the words in the right way. So help me out.
Okay, so brings a sense of closure to your position. So let's say like if you agree, it when you write your rebuttal, it should stand out to why you agree to this point. And if you disagree, then it should stand out to why you disagree to that point.
Okay, that's true. Um, that's true, but don't use the word sense of closure because sense of closure refers to like if you're ending something. Okay, so
I have another one.
go ahead, Sierra. I mean, Deja.
That you should not just annihilate the person because you don't agree with them, but that you should be open minded and try to agree with them at some point. Even if it's ridiculous, try to agree with them at least an inch or something into their point
Yes.
and don't be arrogant.
Yeah, I like that. That's true. Yeah, make sure you are compassionate with your rebuttals. Make sure it is when you give it, it is done with a sense of empathy. Even though you're right, no one is saying that you're not right, but even though you're right, still show them the respect that they deserve as a human being, right? So that's something. How often do we see that happen in real life, eh? That's interesting, right?
I mean, in government, because when you watch, sometimes they have parliament on TV,
Mm-hmm.
and they have heated debates, but they tend to not. Well, the majority of them
What?
tend to not insult each other personally.
What parliament
A
you
few
think this
times
is?
I watched they did bring up personal stuff, like the
Exactly.
former QC. He
Exactly.
brought up Fred Mitchell's son or something like that
Yeah.
who got arrested at a party or something like that. That was
Eh,
personal.
exactly. And they even fighting then also. So yeah, that could get heated. Um. So yeah, that could get real heated. I think that's an example of what not to do. You're like, okay, that's what not to do. Like, then don't get me started on elections. Elections just be ridiculous. Campaign that is. All right, so that's what we looked at. Um anyone else with what we learned yesterday concerning the rebuttals? Any highlights from yesterday that stood out to you or that you could remember from yesterday's discourse?
Excuse me, what you said? I didn't hear you very.
I'm saying, is there anything that you could remember from yesterday's class that you want to share today on in language? Okay, no. All right,
That
so
there's always two sides of a story.
excellent. So yes, let me pull out the notes from last class. Anyway, um, that was how to write a rebuttal, right? So that's what we looked at last class. How to write a rebuttal. We talked about that when we're dealing with expository questions, when we have questions that requires us to take a side, um, we should not only state our side and provide reasons for our side, but try to include an opposing view. Now, there's a question. Um, how many opposing views should we put into our paragraph? We looked at this yesterday. How many opposing views should we put in our paragraph?
Six?
6? Ooh, child. No, not 6. Certainly not 6.
Two.
At most 2. You want to aim for 1, but at most 2. We don't want to have too much rebuttals or too much opposing views in our essay. Why is that? Why don't we want to have too much opposing views in our different paragraphs?
Because it'll make you look like you're running on.
Yeah, it'll be
Or
too. Go ahead.
yeah, make you look like you're running on. And then sometimes it might not even make any sense what
Yeah,
you writing.
yeah. So you want to have opposing One opposing view per paragraph. That's basically the rule. One opposing view per paragraph. You don't want to write 6, 7, 8, 9 opposing views in your essay or in your paragraph, because it just will be too much to take in, and then you end up arguing and not really defending your point properly. So we don't want to do that. Why provide an opposing view? Because there are always two sides of the story. We looked at this yesterday to show that you have a balanced mind, to strengthen your own arguments, to dismantle. This one was Deja's point, to dismantle or show errors in reasoning which are found in another opposing person's view, to give a comprehensive approach. That means you want to really show that you cover your bases, right? You thought about it, to show that you're a critical thinker. How do you approach the rebuttal? Like we said, you state the person's argument clearly and fairly. The second thing you do is agree. The third thing you do is state exactly why their reason is wrong. And that's when you end with a sense of closure by reaffirming your position. So that was what we did yesterday. Today, we are going to we're going to go right back to principles of writing expository essay. And so if you have this already written, you don't have to write it again. We're going to look at, in particular, general notions about body paragraphs, because we're going to visit my second body paragraph. And so these principles we're going to be looking for again. Okay, so I want Alberni, can you read number 1 for me? Or general notions about body paragraphs. We already covered this, but we have to do it again because we're going to visit a next body paragraph, and so we need to remember or revise these principles. If you have it already written, you don't have to write it again. If you don't, please write it. Go ahead, Alberni.
The body paragraphs must be sequential with respect to how the points were given in the introduction.
Very good. Sierra, can you read number 2?
The body paragraph must have a topic sentence, which is basically the main idea of the paragraph.
Excellent. Deja, can you read number 3?
Every supporting detail you give in the paragraph must correlate directly to your topic sentence, and you ensure that the reader sees this connection. Do not have them guessing about it.
Good. Number 5, Dana Nor.
Use strong, convincing arguments.
Okay. Thank you. And number 4 was make sure each sentence is coherent with the previous statement. Number 6, Jasmine. Jasmine now.
Pardon?
Number 6, read number 6 for me, please.
You say read it.
Please.
Okay. Use example quotes and analogies, conjunctions, etc.
Good. And then finally, number 7, the body paragraph must have a concluding sentence which reiterates the topic sentence and brings a sense of closure to the text. Okay, so what do we mean by number 1? Number 1 says, so I'm just going to talk about it and explain it, and then we go to our essay. So when we say the body paragraphs must be sequential with respect to how the points were given in the introduction. So in the introduction, you give your points. So let's say you talk about, the first point was on water, happiness, and love. So when you go to your first body paragraph, you have to talk about water. Your second body paragraph, you have to talk about happiness. Your third body paragraph, you have to talk about love. In that order. right? You can't mention water, happiness, and love, and then you start off with love. No, you say water, happiness, love. So you must start off first with water, then happiness, then love. Good. Second point is that the body paragraph must have a topic sentence. Oh my, oh my, oh my. Your body paragraph must have a topic sentence. Your topic sentence clearly states what your paragraph is about, and it answers the question at hand immediately. So essentially, I mean, you're not going to write your topic sentence like this, but your topic sentence should basically say, this is why I'm writing this paragraph. This is the point that I'm trying to defend. That's basically what your topic sentence is saying. Okay? So I am showing, my topic sentence probably for water is, I am showing the benefits of water towards school life, whatever. That is what my topic sentence is, and every sentence that I write after that must support that topic sentence. And the topic sentence itself must be in correlation to the question at hand. Good. Number 4, make sure that each sentence is coherent. That means you don't run on, or not don't run on. You don't, you do not, you stay on topic, so you don't go off course. Use strong, convincing arguments. Your arguments must be solid. They must be well thought of. This is what makes you a mature student. This separates the B student from the A student. Maturity in thought, right? Do you think like a 6-year-old, a 7-year-old, or a 6th grader or a 7th grader? Are your arguments convincing? Can they convince me as an adult? Can they convince the examiner who is an adult? Do you show that you have an understanding of the topic? How do you develop strong points? You use examples, use quotes, use analogies, use comparisons, use contrasts. You use different things, different ways, different methods to build up your case. And finally, you want to end with a concluding sentence which brings it all down and sums it all up. So how do we do this in actual practice? Like, we want to see an example. How do we do this in reality? Okay, good. I'm glad you asked. Good. Now, let's begin with my second body paragraph. And in my second body paragraph, you're going to see the same things I mentioned about the general notions of the body paragraph. You're going to see them in my body paragraph. And I'm going to ask you, which point am I doing right now? What am I doing right now? Why am I doing it? And so you're going to see it. So I'm going to ask Deja to read the sentence that is highlighted in yellow. Go ahead.
Secondly, being cognizant of the fact that the history of commercial farming in the Bahamas consistently reveals its inability to provide major, sustained, profitable economic benefits to the Bahama Islands, the Bahamas government should not consider changing the main industry from tourism to farming.
Good, perfect. Question. What do we call this particular sentence? What do we call that? What do we call this particular sentence that we have highlighted? What do we call that?
Topic sentence.
The topic sentence. Very good. So I begin with my topic sentence. What are some characteristics of my topic sentence? What are some characteristics of my topic sentence? What do you notice about my topic sentence?
It's going in order.
It's going in order. Okay. It's going in order to. Very good.
What you're going to talk about in the different paragraphs.
Help me out. It's going in order with. I need to understand what you're saying.
No, I said it's going in the order like what you're going to write about in your paragraphs.
Okay.
So like.
Uh-huh.
Yeah. So like when you say Bahamas constantly reveals its inability to provide sustained, profitable benefits and all that. So those right there are 3 different body paragraphs.
Not 3 different. Not 3 different body paragraphs, but they are. This sentence is following what I said in my introduction. Because in my introduction, the first thing I mentioned was tourism contributes to economic stability. Then the second thing I mentioned was being aware of that the general trend of commercial farming has proven to be unsuccessful. That was my second point. And so when I come down to my topic sentence for my second body paragraph, I am talking about how commercial farming has been inconsistent in providing major, sustained, profitable economic benefits. And I like what you said. You said these adjectives that I use, I am basically preparing the reader for what I'm going to say in my body paragraph. And you're absolutely right. I am going to show them why commercial farming was unable to provide major, sustained, profitable economic benefits. That's what I have to show them, right? And this is basically giving the reader a general idea of what the rest of my body paragraph is going to be. Okay. What else do we see in this topic sentence that is noteworthy? So, yes, it's there. That's the first thing. And the second thing is, well, it's in order. It's in line with what my introduction said. What's another thing that we notice about this um, topic sentence? Anything jumps to you as significant or important about this topic sentence? Going once, going twice. Nothing. Secondly, being cognizant of the fact that the history of commercial farming in the Bahamas consistently reveals its inability to provide major, sustained, profitable economic benefits to the Bahama Islands. The Bahamas government should not consider changing the main industry from tourism to farming.
I don't know. Maybe you're gonna give us some historical information about commercial farming and why. Yeah, yeah. Maybe you're gonna give us the historical background about commercial farming that shows that it should not be changed from tourism to farming.
Exactly. Very good. I like that you noticed that because I prepared you for it, right? I prepared you. It's like going to the dentist, right? If you ever go to the dentist, one of the major reasons why people hate going to the dentist because, well, it's scary, right? At least some people think that, with the drill, the zzz, and when you go in a dentist chair, you sit down. The first thing that they tell you is, I mean, of course, they say good morning, whatever, and they say they would say something like this. When I push this needle or insert this needle into your gum, you're gonna feel a a sizzling pain or a striking pain or a throbbing pain, whatever they'd say, right? But what are they doing when they tell you that? Why didn't they tell you that before they actually do it?
Yeah, so they can warn you before doing it.
Yeah, so they can warn you, right? And why it's good to warn you before they insert that thing in you.
So you don't get caught off guard and jump out the chair and run.
Exactly, right? So you don't get caught off guard, right? So you anticipate it, right? And when you anticipate it, right? Um, when you anticipate it, then it's it's not as bad, right? You can say, okay, well, yeah, I accept that because okay, they told me, okay, good, I know what that is. But they push that in there and then you feel something that's weird, you're like, wow, you think something bad or terrible has happened, right? So you give them an anticipation. It's the same thing with your topic sentence. You are the dentist. Your readers are the patient. You can't just go on talking what you're talking about and you ain't prepared a reader for what you're gonna say, right? So you have to prepare them. So now you ready. You are in anticipation. Okay, I read now. He got to talk about how farming was, how indeed farming did not provide major sustained profitable economic benefits for the Bahamas. He better tell me how. I am prepared now to receive it. So I like that anticipation. The next thing is that we noticed that what I did also was that I answered the question again. I don't know if you noticed that. But, and this is very important with your topic sentence, I answered the question again. And every topic sentence, every time you state your topic sentence should answer the question again, but this time with 1 point. So your introduction, you answer the question with 3 points. That's your thesis. But with each body paragraph, with your thesis, with your topic sentence, you answer the question again, but this time with only 1 point. So here I answer the question again. So I answer the question again, but this time with 1 point. So that's what you want to make sure to do in your topic sentence. Answer the question again. And what I say, I reveal your position again, right? Make sure they understand your point again, but this time with just 1 point. So here, I said, I reiterate my position. My position is still the Bahamas government should not consider changing the main industry from tourism to farming. That's still my position. I reiterate that position, but I state the one reason why. Next thing you would notice here is that I have secondly. What is that doing there? What do we even call that?
Transitional word.
Exactly. We call it a transitional word. All right? A transitional word. So you have firstly, secondly, thirdly, fourthly. I mean, those ones are dry and dull. But then you have stuff like additionally, therefore, furthermore, right? Those are what we call transitional words. They need to be in your thesis, in your topic sentence, right? You need to have transitional words to show the flow of your essay, right? So you need to have transitional words. All right. Next. All right, so continue reading for me, Miss Deja. The result.
The result of relying on farming as a chief source for the growth, development, and sustainability of the Bahamian economy can never be overlooked if
So let me erase all this thing that I have here. Erase, clear up. So that's okay. So sorry, start it again. Started from the result. My bad.
Okay. The result of relying on farming as a chief source for the growth, development, and sustainability of the Bahamian economy can never be overlooked if one were to read the historic pages that relate the events which transpired after the Loyalists inhabited the islands of the Bahamas. You may continue.
Okay, let's stop right there. So, what did I do here, right? So at this juncture, what I'm basically doing is I'm telling the reader, hey, this is where we're gonna look for our support, right? We're gonna look at the historic pages, right? So what am I doing here? Establishing ethos, showing that I am credible. This is not coming from my mouth or word of mouth or my head. We're gonna look through the historic pages. We're gonna look through history, and that history tell us what happened, right? We're gonna look at the events which happened after the Loyalists. This is very important. What am I doing here? I am showing that, hey, I actually have a grasp of history. I know what the Loyalists are. I know what the Lutheran Inventors are. I know who these groups of people is. I know Bahamian history. That's what I'm showing. That's what I'm telling the reader, right? And they're like, who's the Loyalists? What did they do? How did they, encounter? What, how did they, try with farming, right? And so those are things that go inside the reader's mind, because I'm showing credibility, and I am tying. Remember what I said? I said that that farming has proven that it can't provide major, sustained, profitable economic benefits. And so, all right, if I say it's proven that I must go back. I can't go forward, I must go back. Okay, good. Now let's continue.
According to Ennius, post the Loyalists' arrival, cotton became the most extensively cultivated crop in the Bahamas. These plantations were doing more than thriving, for exports of cotton ranged approximately 3,050 tons. However, likened to the Lutheran adventurers who were before them, the Loyalists' success in farming was only short-lived. Ennius noted that after 2 decades of planting cotton, the crop started to decline in part because of the actions of the chenal bug and the inadequacy of the Bahamian soil. The history of agriculture in the Bahamas, which includes the Loyalists' bitter experience with farming, reveals the inefficaciousness of farming to provide continuous revenue for the Bahamian economy.
Okay, good. So several things that I mentioned there, right? So, okay, let me not just say it all. Let me just allow you all to help me out. What did I cite as evidence that you know, farming in the Bahamas has not been able to provide us with major, sustained, profitable economic benefits? What did I use as my support? Anyone can answer.
What was the question again?
The question was, what did I use as my support to show that the that farming was unable to provide major, sustained, and profitable economic benefits to farmers? What did I use as my support?
Okay, you use, I don't know if this right, but I still can try.
Yeah.
The crop started to decline in part because of the actions of the chenal bug and the inadequacy of the Bahamian soil.
Okay. So, good. So I used a past experience with which group of people who came to the Bahamas?
The Loyalists.
The Loyalists. Not only the Loyalists, who else I cite? Which other group?
Lutheran Adventurers.
Lutheran Adventures. What happened to the Lutheran Adventures that also happened to the Loyalists?
The cotton decline.
Excellent. So the success that they had in farming was only short-lived. See, it's very important to understand the words that I use. The words I used were very strategic, right? And it made my argument robust. Notice what I said. I said the history shows us that farming is unable to provide major, sustained. Why do you think I used that word sustained? Why do you think that was important for me to use that word sustained? Right? Sustained. Why was it important for me to use that word sustain in there?
So it could show how they survived.
No. Why did I use that word sustained? So I say that farming was unable to provide major, sustained, and profitable economic growth. Why the word sustained?
It means sustain, like long lasting.
Long lasting. Okay, that's what sustain means, long lasting. Good. So connect that with why I think I used the word sustain.
The cotton, the farming industry, it wasn't a sustaining thing. Like it wasn't like it wasn't successful. Yes, like you said.
Okay.
But it wasn't
Uh-huh.
short-lived. I mean, it wasn't long-lived.
Yeah,
It's only there for a short period of time.
exactly. Very good. Very good. Good. So you're picking up what I'm putting down. So that's why it was very important for me to use that word sustained. Imagine if I didn't use that word sustained. Then my whole argument would have been wrong because I would have end up saying farming in the Bahamas consistently reveals its inability to provide major profitable economic benefits to the Bahamas. That would have been completely wrong for me to say that because it does, we have seen that farming did provide major and profitable economic benefits because look at it carefully. It says exports of cotton range approximately 3,050 tons. That's a lot. So they was exporting a lot and they was making a lot. But my case or my argument is that it's not sustained. And notice that I use the word sustain here um, in my topic sentence. But let's go back to the introduction and see if we have any idea of that. I said, being aware that the general trend of commercial farming has proven in the Bahamas, being aware that the general trend of commercial farming in the Bahamas have proven to be unsuccessful in the Bahama Islands. So what I say? I say, listen, the general trend, if we look at it over time, it's not working. And notice I said commercial farming. So that's a big difference because you have two types of farming. You have commercial farming and you have subsistence farming. Commercial farming, anyone knows what we mean by commercial farming versus subsistence farming?
When you're farming, commercial farming is when you're farming on a large scale to sell
Yes.
and make a profit, and sustenance farming is when you're farming for yourself. You
Yes.
eat the crop.
Exactly. So subsistence farming is farming for oneself and family, right? And it's not done to make a profit. So it's done on a small scale. We're looking at primitive tools and um, you know, but as opposed to commercial farming, which is done on a large scale, which use heavy machinery and all that stuff. That's why I said commercial farming because, subsistence farming is doing pretty well in the Bahamas. I mean, look at it. You have mangoes everywhere. You have avocado, pear trees everywhere. You have mangoes and stuff, and not only mangoes, but pineapple, watermelon, all them stuff. Dilly, you know, but you know, they're all those different types of fruits, and they grow in people's yard and they flourishing. So much so that they dropping and they falling on the ground to waste. So subsistence farming is doing pretty well in the Bahamas, but not commercial. And what I'm showing the reader is that hey, listen, it's it's not successful long term. Yes, it was short. Yes, it worked for a while, but long term is not successful. It's only short lived. All right, and so that's what I was saying in that paragraph. And then with I end with a sense of closure, and I end with my concluding sentence. The history of agriculture in the Bahamas, which includes the loyalist bitter experience with farming, reveals the inefficaciousness, that means inability, of farming to provide what? Notice the adjective I use, continuous revenue for the Bahamian economy. Yes, it could provide some revenue, but continuous. And these are the differences in your essay that make it better. You describe what you're saying, you think about what you're saying, you look at, okay, what could someone say against my essay that would actually tear it and rip it apart? That's why I use words like short lived, continuous, sustained, so that so that my argument could be robust, my argument could be thick, and no one can gainsay or have anything else to say concerning it. So that was the second body paragraph. In the second body paragraph, we saw the principles that I gave to you um, in in the general notions. We saw how the body paragraph was sequential with respect to the introduction. How in introduction I mentioned the second thing I mentioned was farmers in unfortunate history, and in the second body paragraph, that's what I mentioned. You saw how I did start with the topic sentence, preparing the reader for what I'm going to write, and basically giving them the main idea of the paragraph. You saw that everything I wrote in my essay, in my body paragraph, was in line with the same message of farming unfortunate history, farmers' unfortunate history, why they do bad, why it wasn't profitable long term. We saw that I used strong, convincing arguments. I didn't use something in my head or something I find on a weird website. I used credible information, real and concrete history, and we saw that I end with a concluding sentence. So this is what I expect of you when I read your work, and this is what the examiners expect of you when they read your work, and this is going to make your essay even better. And so next time when we come back, we're going to look at the rebuttal to this excellent paragraph. What was the rebuttal? This is a long rebuttal. This is a long rebuttal. A very long rebuttal. Very long opposing view. Interesting. Very long. And so we're gonna look at that and look at or tease out how I did the opposing view once again, and how you can do your opposing view. And it is basically gonna be a review of what we did on yesterday on how to write a opposing view. We saw it with the opposing view to the first body paragraph. Now we're gonna look at the opposing view to the second body paragraph. So hopefully, as we are exposed to this information and this type of writing, and notice if you look at my writing, right, the words I use, the sentences I construct, all of those show you that okay, this writer, they're mature, at least mature for their level, right? In terms of, it's definitely mature if we would consider this to be grade 12 writing. This would definitely be a mature student. College writing, and university writing, not as mature. Could definitely be better. But for your level, this is definitely mature. And so you want to use words that stand out, words that are not simple, but words that show depth and meaning. And you don't want to overdo it, else your paragraph is unreadable. All right, so that brings us to the end of our little discussion tonight. Hopefully you found something that you could take home and say, you know what, I could use it for my essay. And hopefully you learned something tonight. So with that being said, I want you to have a wonderful weekend. Stay safe and take care. Have a wonderful night.
Bye.
All right. Have a good one.
Bye.
All right. Have a good one.